Hey everybody, Craig Bender, field engineer with Canonical, and what I'm going to cover today is some migration strategies. Basically, came up with this. There's three real migration strategies. The one that we'll spend the most time in is kind of a stopgap, a lift and shift using LXD. LXD is a product that provides both system containers and virtual machines, and you can actually take a physical or virtual machine running CentOS and host it on a LXD cluster or LXD server. There are a lot of benefits to that, which we'll discuss. The second one would be just straight data migration. So we have workloads like Postgres, MySQL, things like that. Postgres is pretty much Postgres. We have the right versions. We can, pick the right version, so we're not doing any changes based on the version of Ubuntu. Usually, each version of Ubuntu has a dedicated flavor of something like Postgres. Like Focal, the latest LTS comes with Postgres 12. The next one will probably come with 13. Right, that's just how that works. And then finally, there's going to be the package for package fresh build, and that's going to be the hardest. But that's eventually where you want to get to. And to really learn that, you need to understand package management and a little bit about our repositories, so you can kind of find what you're used to in the CentOS world and what that's named under in the Ubuntu world. And there's also a little bit of difference, and we'll talk a little bit about the repositories like EPEL versus Universe. We can cover that. But that's what we're covering here on that. And then we'll do a little demo, fingers crossed, with migration of a CentOS VM. So if you're not familiar with LXD, or if you are, this is just a refresher. LXD is a daemon that sits over LXC and then also KVM now, and it provides an enterprise REST API that you can, from one node, you can control multiple nodes. You don't have to SSH to a node like with KVM and do it. You don't have to have a different solution that aggregates all your different KVM hosts. This is truly clusterable, true API or enterprise API. We've actually switched. We have a bare metal installer called Maz. If you're familiar with that, it now has the ability to use LXD for our KVM pods, our KVM hosts. That's where you take a piece of bare metal and it turns it into a hypervisor for you, like a really, you think of it as a bare bones OpenStack and without all the authentication and image features like Glance and Keystone. But if you're running containers, you get all the benefits of a container, right? You have the shared kernel, you have a much higher density, you have better performance because nothing is virtualized there. And the benefit of that is that if you have a containerable machine, that means there's nothing specific. It doesn't need exclusive access to the kernel. It's not using kernel mods that are anyway special from the host. You can put that in a container. And if you can't, then you can put it in a VM. VMs are just going to be, you're not going to get the scale out of that. And you can actually take a live machine and migrate it, and that's what we'll demo here. So that's a little overview, and you can always read more about it. If you go to linuxcontainers.org, you'll see the LXD banner. You can actually give it a shot right there, try it in real time. There's a demo server, and you can play around with it. There's 192 different combinations of Linuxes available, from CentOS, Oracle Linux to even OpenWRT that we provide these cloud images of these Linux, and then they run against whatever the host that's running LXD, so Ubuntu. You get that kernel, so you can run a CentOS 6 or CentOS 7 on an Ubuntu 2004 host, and you get all the protection of that newer kernel, including the live patching of the kernel on that host if it's a container. So just to differentiate between the three, again, refresher, it's things like Docker, Containerd. They usually host, even though a lot of us throw like a bunch of processes into a Docker container or make a big monolithic container. The idea behind it was, one application, Apache or Nginx or things like that. System containers smells, and that's what LXD is. Smells, feels just like a VM, right? And now LXD has the capability to run KVM. It just doesn't use libvirt. It uses the LXD API for that. And you get all the benefits of it, of LXD from a standpoint of the management. It does UEFI. You can run Windows. It's not limited to just Linuxes like the system containers are. And that's kind of how they fit, right? If you were to look at a Linux container like Docker, a physical machine, a virtual machine, system containers are kind of a best of breed of all of them. They don't work for everybody. That's where you'd use a virtual machine. But if you don't have that exclusive kernel requirement, they're a really good way to go. So if we're doing this lift and shift again, so what we're talking about here is you have a physical or a virtual CentOS instance. You want to have you want to be able to make sure that you're protected from any zero-day exploits, any high to critical CVEs that are out there. You can go ahead and turn that into a LXD container running on Ubuntu 2004, and you still all your applications are still going to run in the CentOS space, right? So we're going to make a clone of that machine. You can start fresh even. You can just say LXD launch images CentOS/7 and give it a name, and it will just fire up a brand new CentOS 7 without the CentOS kernel. So this is kind of what we do here. So we'll walk through this as we're demoing. We'll do most of this, but it's some highlights. Usually we want to migrate a system that's in a quiescent state, right? So if we want to stop like our syslog, want to stop sysjournal, if you're migrating something with a database, you definitely want to stop those, right? So, and then on the target, make sure you stop syslog on the target. Sorry, that shouldn't have been the slide there. But so workloads, get them as quiet as possible because data does change, and if it changed during the migration, that would be bad. There's also on a cluster or a single host, there's notion of a LXD host password. So if you forgot what it was set to, you can just run that command as root or with sudo, and that will reset it for you. And you'll see where that's used. It's used when you actually run the connection. So here's basically the gist of it, right? So there's a binary called LXD P2C. You can grab that from our GitHub. So if you go to github/LXC/LXD, go to any of the actions. If you scroll down to the bottom, if you're signed into GitHub, you can just download the daily compile of it. That is cross-platform. If you want to actually compile it against a static library, like just say you have interesting versions of CentOS out there, and you have some different library requirements that aren't the standard, you can just build it on your own. So what you have to do there is you download, you install the EPEL repo, and then you install snapd. And once snapd is installed, you just install Go, and then you just git clone it, and then you make LXD P2C. And that's all you have to do. Now, this is the command basically, right? So we're going to run LXD P2C. This is LXD server. That's the URL. And then this is what you're going to call the new VM CentOS. And then this is a file system. So we have multiple file systems. We just list them out here. We also can do rsync arguments. So if we want to do something like we want to make it verbose because it uses rsync underneath the hood, you could say like -vvv, right? And you'll get much more verbose. There's also, you get pretty much any rsync arg applies. So like ignore missing, things of that nature you can do. If you have a file system you want to ignore, or a subdirectory on a file system you want to ignore, you just do an exclude. So again, traditional. So this one at the bottom kind of shows 3 different file systems. We want to move root, var, and srv. Those are the ones we care about, except we don't want to do var cache. And then this port is standard. No need to really change it unless you specified a different one when you set up LXD. And here's the difference. You basically can give it a flag to create a VM versus a container. So with that, we're going to kind of jump into the demo, I believe. So what I have here is I have some machines that I've deployed with our MAS product. So you see I have 3 CentOS 7s, 3 CentOS 8s, and then these Ubuntus are my LXD cluster. And we'll go here first. So look at our cluster that's going. So we have 3 nodes there. They're all online. They're all ready. And then we'll come back here. And what we're going to do here is kind of just do a little bit of bash scripting, and we're going to kind of like get a list of our machines. So if I were to run this command and I want to see, well, what are all my CentOS machines that I've installed out there? Just run the MAS cli, and I'll do a little bit of JQ pairing just to limit the JSON output. Okay, so these are the machines out here have out there. 3, these are the CentOSs, and these are the CentOS 8s. And what we want to do here is, so we want to make sure that we copy the LXD binary. So I grabbed it from GitHub. We could have compiled it as well. And I have it in a folder called LXD. So I'm just going to transfer those over with rsync. So there's our files. So we just sent over LXD and LXD P2C. And we want to make sure that our files are executable, even though we gave a rsync flag there to do a change file. Let's just make sure we're looking at it across all the nodes. So this is basically just doing an xargs out to our machines and then looking at each one. So we're executable across the board. That's good. So what we want to do now is kind of stop the services on our machines that we're going to be converting. So I'm going to go to each one of these nodes, and I'm going to stop our syslog and systemd. So we're going there, stopping journald and stopping our syslog on the targets, or the things we're moving, not targets, source. And let's make sure they're down. Give a couple seconds here, and we can just count them and see. You should have 14 guys that are dead. He's still hanging. One of my hosts is hanging here. I wonder which one it is. 10. So I got four machines that aren't talking right now. So let's see what's. Oh, they're all pinging. Oh no, actually I had 6. So that's right. Sorry, we had 10 is correct. I only deployed 6 this time. All right. So when you actually do that command line, it's going to prompt you for your credentials. It is a temporary credential. So this isn't something that we can, in batch, just start a big migration. Migrations are something you want to take care to do. So if you actually look at the LXD P2C command line, there's a few options here. So let's go to one of our nodes here, and we'll go to node 10. All right, so it's a CentOS 8 machine, and then we should have LXD P2C. So on a LXD side, that you have different profiles that are set up that could have different disks, different networks, different security parameters. Pretty much anything about a machine type or a VM that you can configure, you can have this stored in a profile. So when you're transferring it, you can tell it what profile to send. We already talked about the rsync args. You can have multiple different types of storage. You can have Ceph storage. You can have ButterFS. You can have a directory-based storage or ZFS. So you get these different named storage systems in LXD, so you can give it a flag there, and then type again. That's the container or VM. So you say -t VM, that should do that for you. But configs are interesting. So if you have one value that you want to change as you're converting it, so maybe you want to turn something like security or nesting or something like that on. Maybe you want, if it's a system container, you want to pass through a kernel arg. So let's say this machine had KVM on it, and you want to make sure that you're going to get KVM acceleration inside of the container. So you'll want to be able to add that /dev KVM device to the container. That's where you handle that with config. So you can really kind of tune the machine as you're migrating it over. And those are what those flags are for. You can create just a blank vanilla machine with the no profiles. That'll basically just copy the data, and then the machine will be sitting there with no network interface or anything like that. And that's usually ideal because you don't. The worst thing that could happen is during the migration that there's duplicate IPs, so that we try to avoid that. So it doesn't actually come up when you're migrating it right away. You have to manually start it, but make sure that you've done due diligence if you're going to leave both machines up for a side-by-side comparison, that you give it different host name, different IP address, and whatnot. All right, so we'll go look at our cluster over here. There's no containers or anything on our cluster right now, Reno cluster, and we'll go ahead and we'll start transferring this one. So normally, if I was adding a remote with LXD, I could just go ahead and add credentials, accept the keys, accept the password. I do something like this, right? And that would actually go through and just add me to all of them. And then I could look here and say, let's see what we have. Let's see, well, actually, I'm on the wrong node there. Sorry about that. Let's go back here. That. So we just have this cluster, and then this is the node that's what we're showing over here on the right pane, right? We don't have to go to each node in the cluster because it is a full cluster and it shares all the information across all the nodes, such as images, such as profiles, and such as credentials. So I don't have to go to each node in the cluster to create a remote, but this allows me from this machine to control everything by saying the add remote. So normally what I'd want to do if I was doing a big batch migration, and this doesn't work, but if you're used to LXD at all, just adding remotes, you would think, well, I'm just going to go add the remote to all the machines I'm going to target, and then I don't have to provide that credential during the migration, during the LXD P2C, and that's not the case. You actually do have to add it, and moreover, you have to run LXD P2C as root, so that credential, that certificate acceptance would be done as root anyhow, and not your normal user. We'll go back to our node 10. And let's make sure that we have everything installed that we should have installed. We copied the LXD P2C from over there. Let's see if we have it all set up. I'll kind of show you how you would build it on your own. So if we're going to kind of build this on our own, there's basically one thing we need to install, and that's snapd. And so let's say, let's see if we have a snapd. I forgot if I installed it or not. Yep, so it's there. All right, so we have Go already installed, but if you wanted to install Go via the Snap Store, you just after you install that, you just say, snap install go -- classic. Classic means that it's not strictly confined. But these are the snaps that I've installed. Core is just minimal parts of the OS that all of other snaps can take advantage of. And then there's our Go application. So from there, what we'd want to do is create a Go directory, Go home, and we can kind of build this on the fly. I think I already have a Go profile set in part of my Cloud init. All right, so I'm just basically sending my Go path. This gets done programmatically when it's being set up through Cloud init. But this is basically the real path of the snap binaries on CentOS. And on Ubuntu, it's actually here, but this is a symlink. So if we don't have this symlink to here, this wouldn't show up on CentOS. So always make sure you do like an ln-s of this to snap bin, and that's going to allow you to do classically confined snaps that can write to different places. Strictly confined snaps are limited to writing in their snap directory and the user's home directory, and that's it. It can't write anywhere else because it's supposed to run on Ubuntu Core, which is a transactional-based OS. And then from there, you can just, if you want to create a kind of a statically built, you just download from GitHub, and then you just launch through Go, and it will. We should be able to make that. I didn't have to do sudo make there. And again, this one here that we build is going to be probably tied to CentOS 8, right? And if we wanted to, the best way to do is if you go to GitHub and you just grab the artifacts from the nightlies, and you can that one will be portable across all Linuxes, or should be portable across all Linuxes. This one's going to be statically compiled against the libraries on this machine. So we'll do a little food TV network thing here. Let's. We already have our the one we copied over there. We have our dynamic one. Oh, this one finished. So let's see. Oh, we didn't have GCC on there. Oops, sorry about that. But that's if we had the build tools on there, then we would have made it. So we'll just go over to the one we have over in user local bin that we copied. So we have to go there. So we're going to run our command, and that's basically how it's going to go. Sudo LXDP to C, and we'll call it. So we'll give it the node, one of our cluster nodes. It could be any of them, and then we're going to call it demo test. We'll do the root file system. And we've got to run that to sudo. But with that, since we want to take it, so here's kind of what I was talking about before. This is a temporary client certificate. This is not going to be good for forever. It's not the actual certificate from from the main server. And then our password, you set that password up when you're creating LXD. And you see over on the right that our container showed up there. And then just as it migrates the data, so you imagine you have a lot of data. These are fairly small machines that I just created. The disks are 120 gigs, but they're just basic, CentOS with a few packages added. So it's not a huge image right now. Start getting into, large root file systems, large disks. It's going to take a while. So it's kind of good to go through and benchmark speed. This is a home network. It's not lightning fast. I'm limited to 1 gigabit here. So enterprise networks are going to transfer much faster. So any kind of caveats, limitations you might have with rsync that you're aware of in your environment, those will be the same limitations that you face, with this tool, since rsync under the hood. We could actually do if things are going smoothly, you can go through and do a for loop. Just know that part right there is interactive as far as accepting the certificate and providing the password. Really simply, we're just write a quick expect script to get around it. And then I've had some cases where using the yes utility, where just keeps whacking yes into the standard in works, but it's kind of kludgy. Get a feeling for how long I should have timed it. There you go. So that's done. That one's there. If we wanted to go do another one, 6 was CentOS 7. So we'll go over here. Actually, let's go start this guy and take a look. So if we go look at our demo test configuration, right? There's nothing much to it. We didn't assign it a profile. So it should have just got the default profile, which really doesn't have much in there. It basically tells it to use our default disk pool, which is a ZFS on /SDB. And then this is the NIC it's going to use, just a standard bridge type interface. There can be all kinds of different NICs. We do routed, we can do MAC VLAN, we can do FAN networking, anything under there. And then from the profile, you can have cloud init, different things in a profile that just really customize the machine. So we'll start this one. I'll just show you something here real quick. So 2004.2. And this is the interesting thing. So CentOS 8 with a 5.4 kernel that matches because it's actually getting the kernel from my Ubuntu host, and everything works. If you're used to, if you're not that familiar with Cloud Init, usually there's something called a Cloud Init output log. Just know that under Red Hat around 7.9 decided that they didn't need that log and they're just going to throw it into messages. So if you ever want to kind of look at the setup stuff that happened, it's in var log messages on CentOS. So this is pretty much the automation from the beginning all the way down the bottom. There's some interesting things that if you actually want to make CentOS, you can actually run LXD itself on CentOS via host there. There's kernel args you can do, and you can do that through Cloud Init or through MAZ. Unlike, you don't have to go do the grub edit stuff. You can just provide it when you're building it through Cloud Init, the kernel args. But that's pretty much the demo. So we took a physical machine here over on this guy here. Let's go back to 10. All right, so physical machine, and then we turn that over to a system container that's using, with a newer kernel than what normally would be there. So imagine dropping back to a much older version of CentOS. You can take advantage of the latest, greatest kernel features, still be protected from zero-day exploits from high and critical CVEs, even though your application workload is running on the older libraries and binaries. All right. Again, the data migration is going to be, primary for databases or things that have a working set of data that's easily movable from one node to another. So like if you had a Postgres instance, you just PG dump it, and then you can PG restore on the new Ubuntu node. Those would be my first targets, things that have easily containable data that I can back up and move versus going through a package by package search. Because even though there's all the same packages out there, they're just named different, and it's going to take a little bit of time. I think, like example, there's even little utilities like Column. If you're doing a lot of bash scripting, Column it's in a package called BSD extra utils, and that's what it's called on Ubuntu. But under CentOS, it's called Linux utils extra, right? So there's not a good translation right now. You have to use the tools to kind of go find out which is which, and that's what we'll kind of cover here, this package for package. So it's fairly simple. And really the key is learning about the package management. And there's plenty of cheat sheets out there. I'd like us to compile one because I think I've read some of the ones that are out there. They're kind of older, right? They use older apt commands. They use third-party utilities with apt when you can do all of it with the built-in apt and depackage tools without going to third party. But from a standpoint of installation and removal, these are kind of the correlation. Yeah, ever since Trusty, so 14.04 or later, you don't have to type apt-get anymore. So if you see that in a command, that's backwards compatibility to older version of Ubuntu. You can just type apt, right? Apt install, apt upgrade. When it comes to searching, right? So this is a third-party util here, apt file search path. You can do depackage-s, that'll give you, and then whatever's in that file. Depackage-l will create like a manifest for you, kind of like an RPM QA. Depackage and RPM are kind of at the similar level for providing that information. You can do apt cache search, and that will not only search the names, but also descriptions. So sometimes, package name changes, or a package gets put into what we call, because they're going to rename it, gets put into a transitionary package. So you might need to go find, what that new name is. Example there would be, we had a libvirt, what used to be called libvirt bin as a package, and now it's called libvirt daemon. So somewhere along the line, somebody, if you're used to installing that, app would tell you, hey, that's no longer there. If you've gone past the release with the transition package. Transition package would say, okay, you meant the new version, but once that transition package is gone, we expect that everybody knows the new name of it. and then how to update the system, right? There's usually one full upgrade command, and if you look at your app configuration, the default on Ubuntu is dist upgrade. That doesn't mean the whole distro. It just means go ahead and if there's any dependencies, go ahead and upgrade those. Don't just upgrade one application, upgrade everything in my box and the dependencies. That's the default type of upgrade. So if you just typed in apt upgrade, you will by default get a dist upgrade on Ubuntu. If you don't want that, you have to go change it in your app settings to just be upgrade. So I think there's three. There's upgrade, full upgrade, and dist. Dist is going to get you the most bang for the buck. But if you have pinned versions, you have versions you want to make sure that aren't getting updated at all, and you want to use a single one, then you can just do the single application. You can also specify a name which is upgrade without changing app. So say like apt upgrade Nginx. And then these are the repo management. There's a couple of tools out there. You can always go edit sources list, but yeah, there's tools like apt-add repository. And where those are interesting is sometimes we have these private package archives out there that have different GPG keys that are available on archive.ubuntu.com. So with the apt-add repository, it goes out and grabs that GPG key for you and adds it to your system. Whereas if you just added that PPA, whatever the line turns out for sources list, then it's not going to pull that key down automatically. So you'll see cheat sheets out there that tell you just go edit app sources list. That's fine for Ubuntu repos. For third-party repos, that could even be like NVIDIA or Dell's Open Manage. You're going to need that GPG key. So if they give you what's called a shortcut URL, use that because that's going to grab the key for you. If not, then you'll just have to do like a GPG key add, and it's pretty simple. You just fetch the key and then pipe it through with add, and that'll add it for you. And you do that as root. The notions and terminology is probably pretty important to understand because there's different things that it allows you for support. When we talk distro, when you see dist under our repos, that's basically going to be Ubuntu. That's not the release or the nickname. The release is the actual number, but we go by in the Debian world, we go by the series name, right? So that's the nickname of. There's actually a full nickname, which is like focal fossa. But it's just the first part of that nickname is called the series. So you'll see our repos are broken down by series. And then under that series, there's something called a pocket. And those will provide, the release one is just the name of the series. So you'll see under the archive.ubuntu.com, Ubuntu/dist, you'll see Bionic. That's GA. That's the release repo. Updates are things that have happened, just updates that have happened, not extended security, but just security patches are in there. But they could be, RFEs. They could be all kinds of updates. They're not just limited to bug fixes. Security is kind of, if it is a major thing, they'll put it in there. But security and updates are kind of the same information. Proposed is a gating area. If you want to run bleeding edge stuff, you can add this proposed repo or pocket. And then backports, we don't backport a lot in the Ubuntu world. In fact, I think there's like 6 or so packages in Focal, or maybe even less than that. So we don't backport often. We rev the applications, we rev the kernel all the time. Right. So and we have, I think, minimum of 5 different kernels, and they're all supported like first-class citizens. So you can run slow and steady with GA, or if you want to have the latest, greatest hardware support, we have something called HWE hardware enablement kernel. And then there's 2 versions of that. There's standard, and then there's edge, which is even a little newer. There's a low latency kernel. So 5 different kernels, and you can run any one of them, and you're fully supported under Ubuntu. You're not running anything unsupported. And then the URI, when you talk about a release of distro series, the suites, what's under their main universe, multiverse, that all gets expressed out into a web URL, which gets broken down a little bit differently in apt. But if you go to the browse archive.ubuntu.com and then compare that with the sources.list, you should be able to figure out how that goes. And that's kind of the end of my presentation. And we'll go to QA.